Welcome to Forgotten Corner of Ale, saving query output. Hey, I'm Eric, and the other day I was faced with a task that at first seems super straightforward, as something I could handle in a couple of minutes. And then I looked at it and thought, hey, this is way more complicated than it has to be. So I thought, let's bring you guys along and see if we can figure this out. The task was to grab some data from Business Central and output a JSON. It's something that we have done a million times. So there's a video on the channel how doing JSON to record and record to JSON. There's a bunch of this is not an unknown task. The interesting part here was that the data request it would be natural to solve this with a query. There was a fair amount of data and there were some relationships and so on. So a query would be the natural way of doing that. Let's actually grab some code here. Oh, that's the documentation. We'll get back to that in a second. So let's grab a query. In this case, I'll just take the bank account ledger entries. That's close enough to what I was trying to do. So what can you do with a query? Well, you can do a lot of stuff. In this case, there's a lot of fields, but there are two interesting functions here. There is save as CSV and save as XML. There's no save as JSON. Well, if there was save as JSON, I would be done and not recording videos about this right now. But there's not. There's only save as CSV and save as XML. So if I grab save as CSV, for instance, what can I do? I can pass an outstream to it, and then there are two fields: format, which is an integer, and format argument, which is a text. Which brings me to the page that I just had opened. When in doubt, let's check the documentation. Actually, you can, if we go here and okay, clearly we need an outstream, right? So we can pass that outstream, and then we'll go look at specifies whether the columns of the resulting text sets are fixed positions in the CSV file or separated only by a delimiter. Saves the resulting data to a query as comma separated values. But this is an integer. And then we can let's pass a 6. And then you set the next one, the format argument. You set the format argument parameter based on the settings of the format parameter. If the format parameter is set to 0, not 6, then the format argument parameter specifies the starting position of each column in the dataset. So not a comma separated value, but fixed format. The value is a comma separated string of integers that includes an integer for every column. In a CSV file, each line is evenly divided into positions for holding characters. The first integer, but that's not a CSV file then. The first integer corresponds to the starting position of the first column. The second integer corresponds to the starting position of the second column, and so on. Save the resulting data set as a query of comma separated values. I don't think anybody has ever read this and say, oh, that makes total sense. Unless people think that CSV does not stand for comma separated values, but it's just a text file. And that's why I went to the documentation page, which has the exact same information. And then we see there's a 0 and 1, 10, 40. So that's clearly not a CSV file. That's a fixed format file, as we can see here. So what if we do want to comma separate a file? So let's try. So we could try the one 0, and then we'll do what do we do? 1, 50, 100, 150, 200. I don't know how many columns there are. But if we're going to save to an outstream, then we need an outstream. So let's have a blob, temp blob, and then we probably need to get the data again. So we'll just create an in-stream. So now we'll do blob create outstream. We'll grab our outstream there, and then we'll do blob create in-stream, and then we'll do download from blob, but that will require us to have a file name variable. So we'll do file name equal data.csv. So download from stream. First parameter is clearly our in-stream. Second parameter is a dollar title. We don't care about that. To folder. We don't care about that. To filter. We don't care about that. And then the file name. Boom. So this should create. This should, I guess, save the query as a fixed format thing. I probably need to log in here. Let's see. Getting ready. Oh, I think we have a. There is an exception here. We can go in locals, and then we can look at the AL exception. The query output cannot be saved. The following error occurred: missing or invalid argument positions. Okay, so you know what? I don't even want to, because what I'm thinking, because we need to output. We need JSON. So let's figure out what if we put a 1 here instead? What if we put a 1? Now I kind of not documented. 0 is clearly the fixed format. So I'm hoping that we got a file. Let's open that. Excel is opening on another screen here. So we got something comma separated. I think we might even, if we go back to VS Code and I say open users Eric download data 6 CSV. That is clearly a comma separated file. It's kind of a stupid comma separated file because there's no delimiter, no quotes on anything. So why now we unlock that there's no comma in the data? Okay, so here's my idea that maybe we can turn this into JSON. So what I wanted to do, so let's go back and grab that second, the undocumented. Well, we're already in documented because we said 1, and that's not a document. Only 0 was documented. But what the format argument? What happens if we pass something else? So if we pass, what do we want to pass? $. Let's run this again. Got a download. Let's just open it here. Let's just open it here. Users Eric downloads data 7. Okay, so the second undocumented parameter thing is clearly that now we can override the delimiter character. So the question is, could we pass another thing? No. So our log ran out. So we cannot. There's no way to have this being, being quotes around stuff. Okay. So the challenge here is that if we don't have the delimiter, then we need to use a delimiter that we are fairly sure does never occur in the data. And clearly $, could occur in the data. So the way I usually do this is that I create a text here, and then we can say that, okay, so we, there we go. So we use, let's see if we can do this without me typing wrong all the time. By using a text string, a text variable as an array, we address each character separately. So now we can assign something. So we could do, I think 9, then it's a tab separated file. That might work. We could do, we could probably not do a that usually messes stuff up if we try to do a ASCII 0 delimiter, a separator, because the internal structures behind the scene, that's probably not gonna work. But I have had great luck with ASCII 1. So let's actually try that and see if it works here, because it's tremendously hard to actually produce an ASCII 1 character into a text field. So we got data 8. Data 8. See, that looks nice. Okay, so now I think I know what I'm going to do. So let's keep this one. So the easiest way to take something like that is separated is actually so we can create. If I create a variable here that is a list of text, what I can do now is that. Maybe we should just read this. Yeah, okay. So instead of downloading right now, let's drop the whole idea about downloading. So let's we got an in-stream, so we can say while in-stream not read text, I will read one line at a time. So we need a variable to hold a line. There you go. Then read line. And read text returns the number of characters read, I think. I don't think the documentation doesn't actually tell that, but trust me. So we're interested in if we read something. So the last time it will read a blank line, so there's nothing there. So that would be a 0. So we can do while we can read a line. Then what we can do is to say parts, the array I just created, equal our line, and then use the split function. And we can just pass the separator thing we had. Let's do, where is Excel? Or we can just hang on. Just use this one. So 1, 2, 3. So 3 is the bank account number. That's excellent. So let's do we can just message here. Parts get number 3. So this should give us saving, checking, savings, checking, savings, checking, or whatever. Well, the very first time it gives us the bank account, so the header, right? Savings, checking, savings. There you go. Awesome. So now we have kind of made parts being our fields. But I guess the very first time, before we get into this, let's get those field names. So we could do an in-stream read text line, and now we're just assuming that there is data, that there's always at least a header. And then if we do a field names, and that's a list of text, and now we can do here, and they say field names equal line dot split, and split with our separator. So this read will read the first line with the headers, and then this one will read all the ones with the data. So at this point, I think it's actually pretty close to us being able just to create some JSON. So we could create a JSON array, and then we could do JSON data entry, which is a JSON object, which means that in here we would say data. So always remember that if you're using a variable inside a loop like this, make sure that you actually clear it or put that into a sub function. You should probably put it into a sub function, but here on YouTube I'm just free flowing code. So what we can do now is saying that what can we say? We actually need to go and say, we probably need an incrementer of some sort. That's always an I. So we can do for I equal 1 to parts dot count, do begin, and data entry add, and then field names I comma parts I. And that's not how we do it because it's a list. So field names get I. Wow. It would actually be nice if Ale was clever enough to say, oh, that's a list, so we'll just use the array indexing as just like in C# as a way to get into the list. That would be nice. But hey, we can use get instead. Okay, so and then we go data dot add data entry, boom, and then here let's do message format and data. This should give us a. I think we got a JSON on our hand here. Let's try it. Let's try it. Boom. There's an array, entry number, this one, transaction number, that, bank account, savings, posting date, something. So amount. So here's the problem. That this is for sure, this is valid JSON, but the problem with the world of CSV, and I guess actually sort of, because right now I just started out using the save as CSV. We could have done save as XML perhaps, but the challenge here is with the CSV file is that there's no types. So now it's telling that amount is a string with this value, and perhaps we can improve that just a bit. So let's do decimal, and then we'll do that if evaluate decimal from parts get I, then so evaluate converts a text into a number, and you can all the easy way of remembering this is that if you look at this, so decimal equal this, you cannot do that, but that's the order of things. So if we can evaluate the content of the string to decimal, then it's probably a decimal. So we could go data entry add field names get I, comma decimal. Otherwise we will just go with string. So now you see amount is now an actual amount, and there's no longer the comma, because apparently save as CSV is will take your local your region settings and actual format for them, which is not proper JSON anyway. So we could, and I know this video is getting long, so but we could do the same thing, because I also looked at the dates and saying that's kind of not right. So we could do the same with the date time. I think we also could do it with Boolean actually. So we can say if evaluate what I call datetime, comma parts get. So if this can be evaluated as a datetime, then we will pass this as a datetime. Wow, datetime. We could also do if evaluate as a Boolean, then we need to go and grab this thing as a Boolean. I think this will work. If it can be evaluated as a datetime, put a datetime in JSON. Or otherwise, if it can be evaluated as decimal, put decimal in. You could also perhaps do an integer if you really wanted to have the difference between integer and decimals. Otherwise, Boolean. Otherwise, just hit it. So let's see that. Let's see that. Okay, so now you see dates are correct. There's still a string, but the internal formatting is now proper JSON. This is how you put a date in a string. Can't remember if there are any booleans And hang on, we can see that over here. Let's just take a quick look. True. There is clearly a Boolean somewhere. So open, true, no quotes around it. So that's a proper Boolean value. So now we have kind of taken. I think we're close to mission accomplished. Let's see. Of taking a query and outputting a JSON. It would be much nicer if Microsoft would just create a save as JSON and output a JSON object instead. Right now it's just outstreaming, which is, okay. Hey, bonus content coming up in a second. That's how you do a query. Get the output of a query as JSON, or at least that's one method. What happens also here is kind of interesting. So bonus content, you're free to go, have fun, look at the video and all that good stuff. But let's talk about something interesting here for a second, which is memory consumption. And in reality, I don't care about memory consumption because that's Microsoft's problem on their servers, right? This is running in the cloud. I don't care. Dear Microsoft, make sure there's not memory for whatever I come up with of crazy schemes. But maybe I do care just a tiny bit anyway. And I see a lot of scenarios also in Microsoft's own code where we basically end up in a situation where we're duplicating stuff in memory. And in this case, we are, because, right, we have the blob, which has the output of the query, and then we create the JSON object and all that. So basically we have the same thing twice in memory. If you have scenarios where you get something in that is base 64 and you need to convert that, and then you need to convert from the text. Let's say you get a JSON in as base 64, which is not an uncommon scenario. So you get the original data with the base 64, and then you unbase it to something. So now you have another representation, and then you convert that into JSON. So you might have the same thing 3 times in memory, and if that's 50 megabytes or 100 megabytes or whatever, it takes a lot of memory. And I think, and then this is what puzzles me, is that apparently it has not been identified. I don't know what the correct definition is by Microsoft to be an issue, because we have all these cases where you get something out of a web service, you get HTTP content, and then you get into a string, and then you convert the string to A, and then you convert A to B before you can put it into C, and so on. And you get all these memory duplications going on. And I think there is a medium low-hanging opportunity from Microsoft to reduce a lot of memory usage by creating these connected functions. So because it's always the same thing that's happening. Typically base 64 is involved. Typically JSON in and out of JSON objects these days. Nobody does CSV or XML anymore. And you could create all these things as a streaming operation. So we don't need all this memory. And I'm kind of surprised that Microsoft has not already addressed this, and it has not been identified as an opportunity, because when Microsoft are running Business Central and Scale, there is, and I have no idea the number, but there's hundreds, there's thousands, there's millions of tenants running on one little tiny server, and you know, the more tenants and environments that be put into a server, the more profit Microsoft will make from the per user payment that they get. So if you have one server that handles 100 users instead of one server handles 10 users, then that server is 10 times more profitable and stuff like that. And I don't know. I just think that I quite often we end up in this situation where we got memory duplication going on due to the fact that it's instead of connecting these functions together in a streaming kind of scenario, it's like we go from A to B and then we go from B to C and so on, and memory is accumulated. Anyway, sorry, that was bonus content. I will now stop talking, and I'll recommend you go watching this video because it's a good one. I'll see you there. Take care. Bye.